All right, so let's work on guided practice problems. So there's an issue here. This is supposed to be a 4. Just caught my typo. So it should be the 4th root of x to the 5th. So that means I'm going to, before I even take the antiderivative here, for my indefinite integral, I'm going to make this x to the 5/4 dx. And then I'm going to take my antiderivative because it's an indefinite integral. So this becomes x to the 9/4 times 4/9 plus a constant. Then for b, before I go through here, I'm going to square everything. So that's going to give me the integral of 1 plus 2x plus x squared all over x squared. Now, this is, I can't deal with quotients, so I'm going to go ahead and divide that through. That gives me 1 over x squared, 2 over x, because I simplified the 2x over x squared, and x squared over x squared is 1. Now I can go ahead and find my antiderivative. So this is really x to the negative 2. So when I take its antiderivative, it becomes negative x to the negative 1. This becomes 2 natural log of x, and the 1 becomes an x plus a constant. So to simplify that, I end up with negative 1 over x plus 2 ln absolute value of x plus c. All right, and this last one, we're going to need a trig identity. So this isn't one that I typically keep memorized, but I know that it's there, so I can look it up if I need it. But sine of 2x I can rewrite. So the first thing I'm going to do is simplify this because I can't do division. And I can't just cancel the signs together. So the sine of 2x is the same as 2 sine x cosine x, if you look up your identities. And you divide that by sine x. Now I'm allowed to go ahead and cancel my signs. And that gives me the integral of 2 cosine x dx. I'm also allowed to bring that 2 outside because it doesn't have any x's. It's being multiplied. So I really just have 2 times the integral of cosine x dx. And the antiderivative of cosine is sine. So this is just 2 sine x plus a constant. Moving on to number 2, we're going to evaluate the definite integral this time. So let's find our antiderivative. Our antiderivative here becomes 1/10 x to the 5th plus 1/16 x to the 4th minus 1/2 x. And we're evaluating from negative 2 to 0. So I get, when I plug in 0, all of it goes away. So I get 0. And when I plug in negative 2 to the 5th is 32, so that becomes negative 32 over 10, which can be reduced, but we'll do that later. Negative 2 to the 4th is 16, so that becomes just plus 1. And negative 2 times negative 1/2 is positive 1 again. And so I end up with 32 over 10, which is 3.2, minus 2, so that comes out to be 1.2. All right, so don't forget to distribute your negative. That's where I have the positive 3.2 and the negative 1 and negative 1. In B, we're going to rewrite this just so that we know. This is the integral from 1 to 2 of 1/2 x. I like to pull the number away from the fraction, minus 2 times 1 over x. Then I can see what my antiderivative should be. And in this case, it should be 1/4 x squared minus 2 ln of absolute value of x. And we're evaluating from 1 to 2. So when I plug in 2, I get 2 squared is 4, so that's 1, minus 2 natural log of 2. And when I plug in 1, I get 1/4, and the natural log of 1 is 0, so my second term goes away. And so I just have 1 minus 2 ln 2 minus 1/4. And that turns out to be negative 0.636. And lastly, for my definite integrals, we're taking the integral from 0 to pi over 4 of secant theta tangent theta. Secant theta tangent theta is the derivative of secant. So this will become the secant of theta evaluated from 0 to pi over 4. So when I plug in, that's the secant of pi over 4 minus the secant of 0. And let's see, secant is 1 over cosine. So this is 1 over the cosine of pi over 4 minus 1 over the cosine of 0. And we know the cosine of 0 is 1, so the second term becomes 1. And the cosine of pi over 4 is our root 2 over 2. So this is root 2 over 2. But 1 over that. So that gives us 2 over root 2, which when rationalized actually becomes square root of 2. Either way, however you like it, minus 1. And if you use your calculator, if you want a value, that turns out to be 0.414. All right, and then lastly, we've got our velocity question. So first we're going to find the displacement. So that means for question A, whoa, sorry about that. iPad's jumping around on me. For part A, we're going to find the displacement, which is the integral. Ignore this P, by the way. I don't know where that came from. We're going to take the integral from 0 to 3. Of 3t minus 5 dt. And when we get through that, we get 3 halves t squared minus 5t evaluated from 0 to 3. And when we plug in 3, we get 9 times 3 is 27 over 2 minus 15. Minus, when you plug in 0, you get 0. So this is just 27 over 2 minus 15, or negative 1.5. Now notice both of our displacements were negative. They don't have to be, but they can be. For B, the distance traveled, we're taking the integral from 0 to 3 of 3t minus 5 dt, but absolute value because we want the total distance. Okay, so we're going to take our integrand, which is the 3t minus 5, and set it equal to 0. So t is equal to 5/3. So we're going to be splitting up our integral at 5/3. So we want this from 0 to 5/3 of the absolute value of 3t minus 5 dt plus the integral from 5/3 to 3 of absolute value of 3t minus 5 dt. Now the question is which one of these is positive and which one of these is negative. So let's test a point. So any value between 0 and 5/3 would be 1. If I plug in 1, 3 minus 5 is negative. So that means that the interval from 0 to 5/3, 3t minus 5 is negative. So if I want the absolute value, I have to take the opposite of that. Sorry, my handwriting's not the best today. But if we plug in a number between 5/3 and 3, like 2, that gives us 6 minus 5. That's positive. So I can drop my absolute value knowing that everything's positive on that interval. And now I'm set, ready to go. So I'm going to take my antiderivative. So negative 3 halves t squared minus 5t evaluated from 0 to 5/3. And I'm going to add to that 3 halves t squared minus 5t evaluated from 5/3 to 3. And really, there should be a set of parentheses there. Okay. So I can distribute that negative. I might as well do that. So that's negative 3 halves t squared plus 5t evaluated from 0 to 5/3. So when I plug in 5/3, I get negative 3 halves times 25 over 9 plus 25 over 3. And when I plug in 0, I get 0. Over here, we get 3 halves times 5/3 squared, which would be 25 over 3, minus 25 over 3. And Oh, sorry. Apologize. That's the second part. Let's try that again. Over here, we're plugging in the top number first. So 3 squared is 9. 27 over 2 minus 15. That's what we get for the 3. Minus, when we plug in 5/3, we get 3 halves times 25 over 3 minus 25 over 3. And if we plug all of this into our calculator, we'll get our displacement, or sorry, our total distance. So let's see, we get negative 25 over 6 plus 25 over 3 plus 27 over 2 minus 15. And then I'm going to distribute this negative. So this will become negative and this one will become positive. So that becomes negative 25 over 6. I missed something here. Let me fix it. This shouldn't be a 3. It should be a 9. So that when you cancel it with a 3, that becomes a 25 over 6. And then we're adding to that 25 over 3. And I've got 6.83. And that makes sense because our total distance should be larger than our displacement.